All right, so this is the constant velocity equation review, and I want to kind of go over what each of these things mean, what each of these letters mean. All right, so we are going to look at x sub f. So this right here means final position. Okay. And so final position is just where the object ends up. And that translates to y in our y is equal to mx plus b. And this right here means velocity. So velocity, and this is time, and this is initial position. Now, final velocity, as you remember I just said, goes with the y-axis. So it's basically our y-axis on a position time graph. And velocity is our slope, and time is our x-axis on our position time graph, okay? And initial position is our y-intercept. Okay, so now that we kind of reviewed what each of the letters mean in our equation, let's go ahead and answer these questions, okay? How can you calculate delta x from this equation? So we have delta x, if you remember, is displacement. And so in displacement, we are just really looking for the difference between your final position and your initial position. So we're looking for the difference of your final minus initial, and that's going to give us displacement, which is delta x. And in our graph on a position time graph, so on a position time graph, how do you know which direction the object is traveling from this equation? And so our slope will tell us what direction the object is traveling. So we have a positive over and then a negative, right? So this is our positive direction, and this is going to show us our negative direction. And so a positive slope means positive direction, and a negative slope means a negative direction. So it's the sign of our slope. Next, the part of the equation that tells us about our object's starting position is going to be x sub I. So this tells us our object's initial position or starting position, and the units would be in meters. Okay. And so, like in algebra, you have been learning that y is equal to mx plus b as the slope intercept form. And this will give us this kind of a graph. Okay, so it'll be either this or it might also be this, right? So it could be a positive or a negative slope. Either way, this gives us a linear relationship. Okay, actually that L kind of looks like an E. Let me rewrite that. So this gives us a linear relationship. And when it is positive, right, when it has a positive slope, this is a direct linear relationship. And when it is a negative slope like this is going to be an um, inversely related. Okay, so that's that part. Now for the second part of this page, so we've done number 1 as a class, and so we're going to go ahead and work on number 2. All right. And so what we have is Allie starts at 5 meters and takes 6 seconds to travel 40 meters. Meanwhile, Bryce starts at 0 meters and takes 6 seconds to travel 50 meters. How fast were Allie and Bryce traveling? How much is each person's displacement? So I'm going to say person A is Allie and person B is going to be Bryce. And I'm just going to assign this so that I remember now what color I'm assigning which object or person. And so we have here at 0 seconds, 0, and then 1, 2, 3, 4, 5, and 6. Allie starts at 5 meters and takes 6 seconds to travel 40 meters. So she's going to travel plus 40. So that doesn't mean that she ends up at 40. To travel 40 meters means that she's traveling um, 40 more meters than what she was at, right? So she was traveling at 5. She started, sorry, at 5, and now she's going to end up at 45. So she started at 5 and will end up at 45 meters. You don't really have to fill in the stuff in the middle. I mean, you can, but it's going to be a little bit harder to figure out what those intermediate points are. And I'm okay with it, with you not filling it out now. Okay. And so now Bryce also traveled for 6 seconds. So 0, 1, 2, 3, 4, 5, and 6. And don't forget to put in your units. And so then Bryce started at 0 meters and he takes 6 seconds to travel 50. So since there is no starting point, it's just 0, we're just going to add 50 meters to wherever he started. Okay. And so now let's go ahead and graph. So Bryce started at 0 and ended at 50. So I'm going to use my line tool and I'm just going to draw a line between 0 and 50. All right. Now Allie started at 5, so I'm going to find a point halfway between 0 and 10. So here's 5. And she ended at 45 meters. So it's going to be between 40 and 50, so the halfway point there. And I'm going to use my line tool, and I'm going to go ahead and draw a line between 5 and 45. Now it's not perfect, but it'll do for now. All right. So now in calculating the velocity, we're going to go ahead and calculate Allie's velocity. And Allie's velocity is going to be, so I'll just draw an A or a V for velocity and Allie's for as a sub. All right, so we have 45 as her final minus her initial of 5 over 6 seconds minus 0 seconds. And what we're going to get is 45 minus 5 is 40 meters over 6 seconds, which is going to give us, when we put that 40 divided by 6 into our calculator, is going to be 6.7 meters per second. And now for Bryce's, so Bryce's velocity, he ended up at 50 meters and started at 0 meters. And it took him 6 seconds to travel. So 50 minus 0 is going to be 50 divided by 6 minus 0, which is 6. So we'll get 50 meters divided by 6 seconds is equal to 8.3 meters per second. So now we have Bryce's velocity at 8.3 meters per second, and we have Allie's velocity at 6.7 meters per second. Now to calculate their displacement, Allie's displacement is just going to be 45 meters, which is her final, minus her initial of 5 meters, and it's going to give us 40 meters, which was stated in the problem, and so we're just double checking our work. Now delta x here, 50 meters, final position minus initial position is going to be 50 meters, okay? And for our mathematical model, now Allie's is, so remember we're starting off with y is equal to mx plus b, and we are going to go down to the next level, which is x sub f is equal to velocity times time plus initial position. And we're going to just replace all those placeholders with what it means for each person's motion. So Allie had XF. Her slope was 6.7 meters per second times her time of t plus her initial position of 5 meters. Now, Bryce had a final position, and his velocity is 8.3 meters per second times time. And he did not have an initial position other than 0. So you don't actually have to write the 0, but I'm writing it just so you can see it. And so that is it for slide number 4 in week 11. If you have any questions, please make sure to ask.